Hello everyone and welcome back to exercise number 50 of the SolidWorks basic tutorial series. In this video, we're going to be designing a fluid distribution manifold. Now, as always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature. But later, as we will see in this video, in creating this pipe section, this elbow section, as well as this horizontal section, we're going to be using the swept boss base tool, in addition, of course, to the swept cut tool to create the opening for the pipe. Here we see the schematic drawing for exercise number 50. All dimensions are in millimeters. If we zoom in closely, we see that the unit system is set to millimeters, grams, and seconds. We have the isometric view, the dimetric view. These are two different pictorial views showcasing the physical features for the component. We have the front view, the top view, and the section view. And the section view is taken along this horizontal line, section AA. In addition, of course, we have the bottom view. The bottom view basically showcases all the necessary details for the bottom flange, and we can see very clearly that we have 6 mounting holes for this bottom flange that are 10 millimeters each, set on a pitch circle with a diameter of 80 millimeters. So it's important that we take note that we have mounting holes for the bottom flange. So the overall strategy here in modeling this within SolidWorks is that we're going to adopt a feature-driven approach. So if we look closely here, we have a number of cylinders, in this case pipes, all connected with each other. So we're going to be using the extrude boss base tool a lot, and of course setting the end condition as up to next. But specifically, if we look at the front view here, we see that we have a pipe running along horizontally as well as vertically. And of course we have an elbow section here connecting the two directions, the horizontal and the vertical direction. So for this part of the component, we're actually going to be using the swept boss base tool. We're going to draw a circle, and then as well as we're going to sketch out the 2D path. If we look here at the section view, we see that we have a center line showcasing the path for the swept boss base feature. All right, so we're going to be sketching that and then creating the pipe section here. But of course, the first step we need to create this is creating this horizontal section, which involves nothing but drawing a circle and then using the extrude boss base tool. And then we're going to create these lug holes using the same process by sketching out the 2D profiles. For the other two copies, we're going to be using the circular sketch pattern tool. And then we're going to use the extrude boss base tool to create the thickness here. Of course, also, we have this oval flange here, the flange here at the top. So it involves sketching, using many of the sketching tools. And yeah, that's pretty much it. We don't have a lot of important features for the components. So it just pretty much involves drawing circles and then using the extrusion tool, whether that may be the standard extrusion tool or the swept boss base tool. All right. Okay, so with that aside, let's get started with exercise number 50. Okay, so to start, let's go ahead and create a new SolidWorks part. Let's set the background to plain white, and let's copy exercise number 50 into SolidWorks. Let's go ahead and drag this upwards and make it smaller. All right, so as I said previously, the first step in this exercise is to work on the midsection, this horizontal cylinder of the manifold. So to get started, let's go ahead and select the front plane, sketch, and starting from the origin here, let's go ahead and draw a circle. If we look closely at the front view, we see that the base of the cylinder here has a radius of 14 millimeters. So this needs to have a diameter of 18 millimeters. All right, so now press the S key, extrude boss base. Let's set the end condition as up to mid-plane here. So we're going to perform a mid-plane extrusion. And we're going to set the extrusion length here, if we look closely at the top view, as 80. So for this cylindrical section, we have an overall length of the cylinder as 80 millimeters. All right, so enter a thickness of 80, and then click OK. All right, so now what we need to do is we need to create these mounting lugs. Okay, and if we look closely here, we see that the best way to do that is to sketch the 2D profile of one of these lugs. And then we're going to use the circular pattern tool to create the other two copies, and then followed, of course, finally by an extrusion process to create a thickness. So let's go ahead and select this front face, sketch, activate the circle tool, and starting from this point, draw a circle. Set the relation between this point and the origin as vertical by pressing V on your keyboard. Activate the Smart Dimension tool. We see here that the diameter of this larger circle for the mounting lug has a radius of 10, so the diameter needs to be 20 millimeters. So this needs to be 20. The distance between the center of this circle and the origin is 50 millimeters. This is according to the 2D sketch here, the front view. And what we're going to do now is select this face, select Convert Entities, activate the Line tool, and go ahead and connect this circle with the bottom circle here using two vertical lines. Activate the Trim tool, and what we're going to do is we're going to delete any extra entities, leaving behind the 2D sketch for the mounting lug here. All right, so now the sketch is fully defined. What we need to do is go ahead and select Circular Sketch Pattern. For the entities to pattern, go ahead and select the sketch you just created. And set the number of copies as 3. Of course, the condition here is set to equal spacing, all right? And then click OK. All right, now press the S key, extrude boss base. Set the end condition as blind by right-clicking on your mouse. Or actually, it's always set to blind here, so go here, select blind. And go ahead and select these 2D profiles here. Reverse the direction of extrusion and set the extrusion thickness. If we look at the top view, we see that the thickness for one of these lugs is 10 millimeters. So this needs to be 10 millimeters. All right. Now what we're going to do is we're going to open up the holes for these mounting lugs. We could have done that in the previous sketch, but we're just going to do this right now. So select this face, sketch, activate the Circle tool. Starting from this point right here, draw a circle. Smart Dimension. This has a diameter of 10 millimeters. Select Circular Sketch Pattern. Entities to pattern. Go ahead and select this circle. Set the number of copies as 3. Click OK. Press the S key, extrude cut. Right-click on your mouse and set the end condition as up to next. All right, and then click OK. So that creates the opening for the mounting lugs. Now I realize that we have an opening here for the middle horizontal cylinder for the manifold, but there's a reason why I still close it up. Okay, we're going to open these holes up at the very end of the exercise. Now we're going to work on creating the base flange for the component, in addition, of course, to the pipe connecting the horizontal section and the base flange right here, the vertical pipe. So what we need to do is we need to create a new drawing plane. So on my keyboard, I actually created a new shortcut for creating a drawing plane instead of going to features and then selecting plane. The easier way for me to do that is press Control P. All right, and I want to create a new drawing plane in reference to the top plane. And the top plane here basically divides this 3D model in half, right? So if we look at the top view here, we see, or the section view actually, if you look at the section view, you see that if we want to create a new drawing plane to draw the circle representing the base of this flange here, we need to create a new drawing plane that is exactly 100 millimeters away from the origin. So go ahead and flip the offset direction and set the distance as 100 millimeters. All right, and then click OK. Now we have that new drawing plane, so right-click on this new drawing plane and select Sketch, activate the Circle tool, and starting from the origin here at the dead center, draw a circle. Activate the Smart Dimension tool. We see that the diameter of the base flange is 100 millimeters. So this needs to be 100 millimeters. All right. Now press the S key, extrude boss base. Set the extrusion height to 10 millimeters, because if we look here, we see that the thickness of the base flange is 10 millimeters. And click Enter, or press Enter. All right, now we're just going to need to hide this new drawing plane. We don't need it anymore. Select this face, sketch, activate the Circle tool. From the origin, draw a circle, activate the Smart Dimension tool. you see that the pipe connecting the middle section with the base flange should have a diameter of 60 millimeters. All right, so this needs to be 60 millimeters. Press the S key, extrude boss base. Right-click on your mouse and then select the end condition as up to next. All right, so that creates the extrusion all the way to the curved surface here of this middle section, this horizontal pipe, and then click OK. All right, so the component now is slowly starting to take form. But if we look at the base flange, we actually have 6 mounting holes. So let's go ahead and select this face, sketch, activate the circle tool, draw a circle. Now this circle here represents the pitch circle, helping us to position the mounting holes. Select this circle and then press Q on your keyboard to convert this to a construction geometry. All right, activate the Smart Dimension tool, and if we look at the bottom view, we see here that we have all details for the base flange, specifically the mounting holes. So we have 6 mounting holes. Each hole has a diameter of 10 millimeters, and the pitch circle here has a diameter of 80 millimeters. So this needs to be 80. Activate the circle tool from this point right here. Draw a circle. Smart Dimension. Set this as 10. Select circular sketch pattern. Introduce the pattern. Go ahead and select the circle. Set the number of copies to 6. And then click OK. All right. Press the S key. Extrude cut. The end condition is already set to up to next, so simply click OK. And that creates the mounting holes for the base flange. All right, so now what we need to do is we need to work on creating this this pipe here that protrudes from the component to the left, this horizontal protrusion, in addition, of course, to the elbow here to the right of the component. So what we're going to do, and this is, I want you to pay attention here. First of all, we need to create a new drawing plane that is in reference to the right plane of our component right here. And it should be at a distance of exactly 100 minus 20 millimeters, all right? So that's 80 millimeters. So we're going to be exactly along this edge right here. And then we're going to draw a 2D profile, basically the direction or the path for the swept boss base tool that we're going to be using, the circular swept boss base tool, all the way to the top here, all right? So let's just go ahead and create the 2D sketch. So we'll go ahead and select front plane, sketch. Let's put this to the side, activate the line tool, and starting from this point all the way to the origin, draw a line. Smart Dimension, this needs to be 80 millimeters. Activate the line tool again, from the center here all the way, and create a vertical line. Smart Dimension, the distance, we look closely here, it should be 190, since this is 80, right? We already specified this as 80. So, or actually what we should do is say this is 190 minus 100, gives us 90 from this point all the way to this vertical line here is 90 millimeters. So this is 90 millimeters in relation to the origin, of course. And as for the vertical component here, the y-axis, we need to create a path that goes all the way, not to the top, but to the end of this region right here, this edge right here. So the oval flange here actually has a thickness of 10 millimeters. So it's 70 minus 10, which gives us 60 millimeters. So this is 60. All right. Select the fillet tool, and we're going to assign fillet radius for this edge, and we're going to set the fillet radius as 40 millimeters. So assign a fillet radius of 40. Okay, so that creates the path for the 2D, for the 3D swept boss base tool. Click OK. Exit sketch, and what we're going to do now is create a new drawing plane. Okay, so on your keyboard, press Control P. The reference plane that we're going to be using is the right plane. And we're going to create or offset this. Let's select flip offset and offset this drawing plane at a distance of 80 millimeters. All right. and then click OK. Now, very simply, just right-click on this drawing plane, select Sketch, activate the Circle tool, and starting from this point right here, draw a circle. Smart Dimension, we see here that the diameter of the pipe should be 50 millimeters. And this is 50 millimeters for this left section of this pipe, as well as the elbow pipe to the right. So activate, or actually define, the diameter here as 50 millimeters. All right. So now exit Sketch, go to Features, select Swept Boss Base. And as for the path, just go ahead and select this region right here. All right. Now, since the results here are actually merging with the original solid that I created, SolidWorks will account for any intersecting solids. So don't worry, don't think that we actually created two independent solids, two independent volumes, and the final volume or mass is going to be the algebraic addition of these two volumes. No, it will account for any intersection that we have for this component here. All right, so just to make sure, we look at the options here. You see we have an option here that says merge results. So then click OK. Right click on this plane, hide the plane, and that creates basically 90% of the 3D model. We just need to create certain features for the pipe here. So go ahead and select this face, Sketch, Smart Dimension, Circle, draw a circle, Smart Dimensions. We see here that for this circle here, this cylindrical region, we have an overall diameter of 60. So this needs to be 60 millimeters. Press the S key, extrude boss base, set the thickness as 20 millimeters. Select OK. All right. Now we're going to work on creating this flange here, the oval flange at the top. So select this top face, Sketch, draw a circle from this point here, another circle directly overhead. Set the relation between this point and this point as vertical. Smart Dimension tool, and if we look closely, we see that the circle, the diameter of the larger circle is 60 millimeters. So this needs to be 60. And for the smaller circle, it's 30 millimeters. This is 30. Right? The distance between this point and this point is 50 millimeters. Based off, of course, the fact that from one end to the other, it's 100, so half of it is 50. So now activate the circle tool, the line tool, and just connect these two circles using tangent lines. That's 1 and 2. All right. Just make sure that we have the tangency conditions for each entity relative to their respective circle. In this case, everything seems to be okay. Now we're just going to draw a center line, a horizontal center line right here. Press the S key, select mirror. For the entities to mirror, we're going to select this circle in addition to these two tangent lines. Mirror about this horizontal line, and then click OK. Activate the power trim tool and delete any extra entities, leaving behind the 2D profile for the oval flange. All right, now press the S key, extrude boss base. The extrusion thickness is set to 10 millimeters. All right. So now we're very close to the end of this exercise. So just needs to open up certain holes. Let's start with the mounting holes for this top flange. Select OK. Draw 2 circles here, 1 and 2. Select these 2 entities. Press E on your keyboard to set the relation as equal. Smart Dimension, we see that we have a diameter of 15 millimeters. S key, extrude cut. Right click, or actually the end condition is always set to up to next. and then click OK. Right. Now, let's very simply create the opening for this pipe here that runs along horizontally and all the way vertically. So for this horizontal section, as well as the right elbow, what we need to do is select this face, sketch, draw a circle, starting from the origin. We see that the opening for the pipe here is set to 40 millimeters. So this is 40. Exit sketch, select the front plane, and what we're going to do is we're going to create the 2D path for the swept cut tool that we're going to be using later on to create the opening for the pipe. All right, so activate the line tool, and starting from this section right here, all the way to this point here. Activate the line tool again from this midpoint all the way to the bottom. Activate the power trim tool, delete these two lines, and we have the path here. So just very simply select the fillet tool. Fillet is set to 40 millimeters, and then select OK. And then click OK, exit sketch. Now go to features here and select the swept cut tool. So that automatically the path has already been selected, the last sketch we just created. As for the 2D sketch, select this circle. All right, and then click OK. And that opens up the pipe here. Now we just need to create the opening here for the front face. So select this face, sketch, activate the circle tool. From this origin here, draw a circle, smart dimension, and the opening here is set to a diameter of 60 millimeters. So assign a diameter of 60, press the S key, extrude cut, press enter. So now we have the opening all the way to the other side. We're going to perform the same operation here at the bottom. Draw a circle. From the origin, draw one circle, activate the smart dimension tool, and the opening here, the inner diameter of the opening is set to 30 millimeters. Press the S key, extrude cut. Okay. All right, so yeah, that's pretty much it. I think we, for the most part, completed the modeling process for the component. We just need to have certain fillets that we need to create and certain chamfers. So as you can see here, there's a note here that says, unless stated otherwise, all fillets have a radius of 2 millimeters and chamfers 2 millimeters by 45 degrees. All right, so let's go ahead and assign the fillets. So select fillet, assign a fillet radius of 2 millimeters. And as you can see here, certain sections right here, edges, need to be filled out. You have this edge, the intersection between these two cylinders here at the bottom, right here and here. And we have the intersection right here at the bottom. All right, and then click OK. Okay, and go ahead and select chamfers. And we only have 2 chamfers. We look at the section view here. We see that we have a chamfer here for the bottom edge of the inlet opening, and we have a chamfer for the outlet for the oval flange at the top. So enter a distance here of 2 inches, this edge, and this edge right here. Click OK. All right, so that completes the modeling process for the components. Let's assign a material, right-click, edit material. Set the material as ASI 1020, apply, close. Now, this is an optional step. You can color the component as you like. So just select appearance. And go ahead and select the nice green color here. Click OK. There are certain faces that need to maintain their metallic appearance, so just go ahead and select these faces. You have the inner faces. Basically anything that's not exposed to the environment. Again, this step is optional here. It's just me being artistic. Okay, now let's go to appearance. Grayscale, let's select this color right here. Okay. All right, we have this section that we are on the inside. Okay. Now for the moment of truth, let's go ahead and determine the mass of this component. So just go to the Evaluate tab, select Mass Properties, and we have a final answer of 3,951 grams. 3,951 grams. That is our final answer. Let's delete this image, set the view to perspective. Okay, so that concludes exercise number 50. I hope you all enjoyed this video. If you found this video useful, please don't forget to hit the like and subscribe button. And also would like to hear from you. So if you have any comments or questions, please leave them down in the comment section below. I hope to see you all in exercise number 51. Until we meet again, bye-bye.